I think today totally we'll go for one more small derivation and then numericals. You have a block of same mass m. It is resting on a table, right? When the block is resting on the table, it exerts a force on the table which is equal to its own weight. Then the table exerts an equal amount of force on the block, right? That what we call it as normal reaction. So these two things you should be clear about it. A block of mass m is at rest on a table. So the block exerts a force equal to its own weight on the table. So if I take this as the table, okay, this as the block, then the table exerts an equal amount of force, which is equal to N. We call this as the normal reaction on the block, so that the block is at rest, because all the forces acting along the vertical directions are equal and opposite. It cancels out. Now, what are you doing is that you're applying a force. Sorry, you are applying it's being shown as P. You apply a force in order to pull the block, right? When you're applying the force and the body just begins to slide, or we can take this as you're applying a force so that immediately there will be a frictional force acting on the block in the opposite direction. Now, for convenience, they have shown that the direction of, sorry, the line of action of the frictional force and the applied force are the same. Actually, the frictional force should lie along the surface which separates both the bodies. So for convenience, they have taken it. So you have applied a force right to the block. Immediately a frictional force is acting left to the block. Now you have to check what is your angle of friction. So you have two forces. I'll just take this as, say this is your frictional force F. Then you have the normal reaction. Can you identify this? I think so. They have marked this point as A. They have marked this point as, sorry, C, this point as A, and this point as B. First, can you identify this in your diagram? So that the resultant of these two forces, what are the two forces? One is the normal reaction, the other one is frictional force. So the resultant of these two are given along the sides of the parallelogram, right? These two forces forms the sides of the parallelogram. The resultant of these two forces are given along the diagonal of the parallelogram. See this, they have marked it as F. So the resultant, so this is the resultant between the normal reaction and the frictional force. Now the question is, what is your angle of friction? Now the angle of friction becomes equal to the angle between the resultant and the normal reaction. Is that clear, boys? 11B?
Yes, ma'am, it's clear.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am. Yes, sir.
Draw the diagram, boys. Draw the diagram, then we'll go for calculating theta. Anyway, you know how to calculate theta. Okay. Because I have to take the triangle, because here they have given it as tan alpha, make it as theta. Diagram they are showing it as, they are representing it as tan theta. Which triangle you'll be taking? Okay, fine. First you copy down the diagram. Copy down the diagram. This tan theta, I'll just come back. Boss, please update your the physics folder at least with the holiday assignment of art integration. So
A lot of students did.
yeah, okay, okay. I have not checked. I'll check today or tomorrow.
Okay.
Thank you. Rishit, Derek, and Danish. Rishit. Rishit is here. Rishit. Derek.
Yes, ma'am.
Danish. Rishit, Derek, and Danish. In your previous school, did you had your holiday homework for you assigned for you, boys? Rishit, Derek, and Danish.
No, ma'am. Actually, before the holiday homework, I left the school.
Okay. Then in that case, Rishit, Derek, and Danish.
Yes, ma'am. They might have cancelled it for us.
Okay,
So
what we'll do is at least this holiday assignment, I have to put your email ID, or any other student can help them only this art integrated holiday homework. Can you? Otherwise, I need your email ID. Let me check with your class teacher. Class teacher is having your email ID, right?
Yes, ma'am.
Or else, boys, or else you are you capable of checking the file section? Rishit, Derek, and Danish. File section. Just check file section. There we have uploaded holiday assignment. I don't want you to go through all the holiday assignment. Only one assignment is there where it has been given as art integration. Can you check this, boys? Rishit, Derek, and Danish today.
yes, ma'am.
Okay. Otherwise, someone of this 11B class, this holiday assignment is uploaded in Phoenix as well as in, I don't know how far these children can access Phoenix, but it is uploaded in the file section of your class 11B. Others, can you help them out where to locate these files? 11B.
The new boys, just click on the link I sent in the chat.
Thank you, sir. Thank you. Right. Only art integration is enough right now. Fine. But shall I go for the other slide? Now you know how to find tan. Let me take this triangle. Triangle, I'll go for ACL. Right? Vishesh, his microphone is working, Vishesh? Vishesh? Okay. In triangle ACL, what is tan
Yes, ma'am.
theta? Vishesh,
Ma'am.
in triangle, okay, fine. Look at this triangle. In triangle ACL, what will be tan theta, Vishesh?
Ma'am,
Opposite
angle
side?
ACL.
AL divided by? Look at this triangle, what I've drawn separately. So in triangle ACL, what will be tan theta? Which is your opposite side for this right triangle? AC, okay.
Opposite side for right AL.
Okay, divided by hypotenuse. Hypotenuse.
CL.
CL. Okay, fine. Now look at this diagram. BC has a value of F. BC is having a value of F. Naturally, AC will also have a value of the frictional force, correct?
Yes, ma'am.
These two sides, boys. These two sides, they are parallel and so I'll go for F. Then what about yes? Sorry, tan theta is was opposite side by adjacent side. It is AC. Opposite side is F. What about adjacent side? Adjacent side has the value N. Normal reaction is correct. So
Yes,
then
ma'am.
tan theta becomes equal to F upon N. And you know F upon N is your coefficient of friction. Is that correct, boss? F upon N is your coefficient of static friction. If you take this as static frictional force, this becomes coefficient of static friction. Boys, are you clear as others? Because so many things are overlapping on the screen. Should I go for another new screen and do, or this overlapping is clear for you?
It's fine.
The only thing is that here they have made an error. So tan theta. Tan theta is equal
Ma'am,
to
can you do this on a new page?
new slide. Okay, fine.
Yes, ma'am.
Fine, I'll. Just check whether what I'm doing, because was this point C, boy? Someone can just check. Was this point
Yes,
C?
ma'am.
Okay, so then I used to have this point is L.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, then this angle was theta, correct?
Yeah.
Fine. And this value was frictional force. Let me take static frictional force S, Fs, correct? This was the normal reaction.
Yes, ma'am.
Okay. So now this value A to L has a value of the static frictional force because these two sides are fine. Now in this triangle, tan theta will be AL divided by AC, or tan theta becomes equal to Fs by N. But we very well know Fs by N is coefficient of static friction. And this depends upon the nature of the surfaces in contact. So tan theta becomes equal to coefficient. What is theta? Theta, we call it as the angle of friction. Is that fine, boys?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Next, we'll go for next one. Might be slightly, I don't know how far it will be clear for you. Next one is angle of repose. We'll see what is angle of repose. Then just write the question, boys. This is how the question will be, and it might go for three marks. A 3-mark question. So for descriptive part. Define angle of repose, deduce its relation with coefficient of static friction. So or else the question might be like this: define angle of repose, deduce its relation with angle of friction. Both means the same. Write the question: define angle of repose, deduce its relation with coefficient of static friction. Okay, fine. Now, angle of repose is the minimum angle that an inclined plane makes with the horizontal when the body placed on it just begins to slide. Now, what does it mean? Suppose if I have an inclined plane, this will be your inclined plane. Now, this will be your horizontal. Inclined plane and horizontal. So now let me keep a body on the inclined plane, right? Now, when I keep a body on the inclined plane, now this plane is inclined at an angle to the horizontal. You know what is an inclined plane? So now you keep tilting your inclined plane, you know, right? You keep tilting your inclined plane. At one point, the body just begins to slide. Are you clear, boys? I have an inclined plane. This inclined plane makes some angle with the horizontal. You keep a body on the inclined plane, right? And you keep moving the inclined plane, tilting the inclined plane. At one particular point, the body begins to slide. That is natural, right? Have you seen? You yourself can check. You keep an inclined plane, keep a body on it. As you tilt, right? As you tilt in that sense, you move the inclined plane, increase the angle of inclination. This angle you keep increasing. At one point, the body begins to slide. Is that clear, boys? So the angle of the inclined plane when the body just begins to slide, we call this as the angle of repose. Should I redo this? 11 B, do you understand this? Suppose, listen boys, I have an inclined plane. I am placing a body on the inclined plane. When the angle between the inclined plane and the horizontal, say phi is equal to 25 degrees, right? The body is still stationary. Now let me increase the angle, say, to 35 degrees. Still the body is stationary. Let me increase, say, phi is equal to 45 degrees. Then now the body begins to slide. So you're increasing the angle of inclination. At one particular angle of inclination, the body just begins to slide. And this angle of inclination, we call it as the angle of repose. Copy down, boys. Angle of repose is the minimum angle that an inclined plane makes with the horizontal when a body is just placed on it, just begins to slide. Okay. We'll start with the diagram.
Now we can draw this.
Yes, you can draw. Before that, I'll just first let me go for this is the angle of inclination where the body just begins to slide. Now look at this. Always, suppose if a body is on a horizontal plane, if the body is on a horizontal plane, then the weight of the body will be acting vertically. Sorry. This you very well know. If the plane is horizontal, then the weight of the body will be acting vertically downwards. Then immediately you will have a normal reaction acting in the upward direction. This is when the plane is horizontal. Now look at this. This is an inclined plane. This is an inclined plane. So the weight of the body will always act from the center of gravity, CG. We call this point as CG, where we assume that the entire weight of the body is concentrated anyway. From the center point, there is your weight will be acting vertically downward. So this weight W is equal to M into G. Now this weight has to be resolved into two components, right? So I draw this separately, you understand. So mg is acting vertically downwards. Is that clear, boys? Because the body is not on a horizontal plane, the body is on an inclined plane. Now let me draw a normal. Let me draw a normal straight line.
Sorry to ask, but mg
Yes.
stands for gravitation, right? Like the magnitude of gravitation.
Yep. Gravitation, it is the weight of the body. That is a force.
mg stands for weight.
Weight, that is a force exerted, okay?
Mg is mass into gravity, so it's weight.
Yeah, weight. Okay, fine. Now at this point O, let me draw a vertical. Do you understand? Vertical means which makes 90 degrees to the plane, right? Now your weight is inclined at an angle phi. This geometry, can you understand this geometry, boys? See, your weight is no more acting, boys. Your weight is no, it's not like this, right? When the body is on a horizontal plane, this is how the weight of the body is going to act. You see the line of action of W, it is along the vertical line or the vertical plane. But now what is happening over here? In an inclined plane, if this is the vertical drawn to the inclined plane. This is a vertical drawn to the inclined plane, which means the weight is inclined at an angle phi with respect to the vertical. Is that clear? If I see this angle is phi, if this is 25 degrees, this phi also will be 25. Because as you tilt your angle of inclined plane, this angle also keeps changing. Now I have to resolve this mg into two components. Can you see? It is resolved into two components. Two components means what? We are splitting that into two parts. When you combine mg cos phi and mg sin phi, you have to get it as mg. You draw this, then let us see how you are getting mg sin phi and mg cos phi. You draw this first. Should I explain how are you getting mg cos phi and mg sin phi?
Just taking the components, right?
Yeah, it is the component. These two are the components. Should I explain you how are you getting mg cos phi? Samuel? Nabil? Nabil and Samuel? Boys, your microphones are not working. 11B.
Ma'am, it works.
Then why there is a time lag? Nabil and Samuel, boys, I'm not asking any question. I'm asking you, should I explain this? How the components, how are you getting mg, the components of mg as mg cos phi and mg sin phi? Samuel?
Sorry, ma'am. Ma'am, I couldn't hear you. This is Nabil.
No. Is that Samuel?
No, ma'am, this is Nabil. Did
Okay,
you call
Nabil.
me?
No, yeah. Should I explain how are you resolving this components, components of mg as mg sin phi and mg cos phi?
Yes, ma'am.
Yes, please. Yes. Okay, then. Fine. Because don't blindly, not only you, I'm just asking you as a representative of the class.
Yes, ma'am.
Because there
I
is no
thought, yeah, I
no,
thought it would
there is
come on later, so like I thought I'd wait.
no, boys, no.
Okay.
Okay. So what? Don't blindly copy, boys, because later on, for you to learn, anyone for that matter to learn, it will be tough. So this point is O. Now what I'll do is I'll make a triangle. Let us construct a triangle, right? So let me make this point as A. Let me make this point as B. So now OB is mg. The value of OB is mg. This is a right triangle. This becomes phi. Is that clear? Boys, others?
Yes, ma'am.
Fine. Now
Yes,
we'll
ma'am.
go for fine. In this case, I'll ask someone to be the Zuhair? Zuhair? Zuhair?
Yes.
In this triangle, are you getting the triangle OAB?
Yes.
In triangle OAB, Zuhair, what is cos phi? Cos phi is adjacent side. Which is your adjacent side? Right
OA.
triangle. Adjacent side OA. Okay, fine.
I mean, yes, OA.
Correct. Okay. Which is your
OA by OB.
hypotenuse? Oh, fine. So then I want OA, right? OA will be OB cos phi. So what is OB? What is the value of OB?
MG.
So OA becomes equal to mg cos phi. Is that correct, clear, boys? So this OA becomes mg cos phi. Can you see that over here? Yes?
Yes, ma'am.
Otherwise, I'll mark this as this point as. Okay. I have taken this as, should I mark this? It will be confusing for you. This is OA. Can you identify OA over here, OB over here? This triangle. Can you identify the triangle OAB over here in the diagram also, boys?
Yes, ma'am.
I don't want to make this confusing. So now this part is over. Can someone tell me what is sin phi? Wait, I'll have to call you. Sanfa?
Yes, ma'am.
Okay, what is sine phi in this triangle OAB? Sine phi is opposite side, right?
Yes, ma'am. Sine 5 is
AB.
AB divided by OB.
Okay, fine. AB divided by OB is mg. So AB becomes equal to mg sine phi. Right?
Yes, ma'am.
Okay, this part becomes mg sine phi, which means this part. Can you identify in the diagram? Both I'm marking with dark black.
Yes, ma'am.
Okay. So if this is mg sine phi, can you identify this is the parallel line? Yes. All the dark lines are the same. Mg sine phi, mg sine phi.
Yes, ma'am.
That's. Now this is only the first part of the diagram. This diagram is enough, but you should know how you have got this, right?
Ma'am,
Yes.
ma'am, why is the angle of repose also given as a phi?
The previous one, take it as theta.
Ma'am, sorry, ma'am, can you repeat that?
No, here the angle, that is up to you. I've just taken it as phi. You can take it as alpha also, not a problem. In the previous case, I have taken it as theta. It is angle
No,
of
ma'am.
yes,
Here both there are two angles named phi.
both, yeah, correct. Both the angles are going to be the same. Mathematically.
Okay, ma'am.
Mathematically, both are same. Say if this angle phi, angle of repose is 45 degrees, this angle will also be 45. If you keep tilting your inclined plane, this angle also keeps increasing.
Ma'am, so both the angles are the angle of repose?
Yeah. Sure. Fine. Now, next, now you tell me where should be the frictional force acting. Okay, fine. Where should I draw the normal reaction? There should be a normal reaction. Why? Because the block is exerting a force on the table. The block is exerting a force on the table. The table will exert inclined plane. The inclined plane will exert a force on the block. Where should I draw the normal reaction? I'll draw at 3 different points. Okay, you just tell me which one is correct. Which one is correct? Let me mark this as 1. This is 2. Which one is correct, boys?
2.
2. How many of you are going for 1? Anyone who can say it is 1? Anyone
Isn't it 1, ma'am?
Okay, someone is saying 1, someone is saying 2. Boys, keep it, it's 2. Okay, boys, if the body is on the block, sorry, if the block is on the table, now you always remember that your normal reaction will be always perpendicular to the surface. Normal reaction will be always perpendicular to the surface. Can you see this? This one.
So the answer is 2.
Yeah, answer is 2. The reason is your normal reaction should always be perpendicular to the surface, which is your surface, the inclined plane. So it is always the second one. Are you clear, boys? Are you clear?
Ma'am.
Yes, ma'am.
Time up.
No, ma'am. Ma'am, the value of it will be like mg cos phi, or like will it be mg?
Yeah. This is normal reaction, correct, boys? This will be a normal reaction. Is that clear? No, I'm just I'm just only identifying the forces. You are just identifying the force. Next, we'll have to. Next step is frictional force. But always remember, your normal reaction should be always perpendicular to the surface. It's time. It's time up, or like you have other class.
No, ma'am, there's still time.
There is time.
9:40, no?
Ma'am, 9:50 is a break.
Oh, okay. Now you start writing, boys. You start writing. I'll go for the next diagram. The same diagram you can draw the rest. So consider a body of mass m placed on an inclined plane. The angle of inclination phi is so adjusted that the body on it just begins to slide. Copy down. Have you completed? Shall I move for the next slide, boss?
Yes, ma'am.
So in this case,
Ma'am, could you go
Yeah.
back to the
Ma'am?
slide?
what happened?
Can you go back? Yeah, I'll just take a screenshot once again. I'm done, ma'am.
Now your diagram, this is your normal reaction, fine. Now, where will the frictional force, because you know very well the body is going to slide down, the body is sliding. So the frictional force will be in the direction opposite to the direction of the motion. So this will be the direction of motion of the body. So your frictional force will be in a direction opposite to the direction of motion. The body is just beginning to slide, which means it will be limiting friction. Now, is the diagram now clear for you? You have mg cos phi, mg sin phi, Fs maximum and normal reaction. Is that fine now? Okay, fine. Now we'll start applying the condition. Now, when the body is sliding down, boys, please understand, the body is just sliding down, right? So in that case, is that the body moving either in the downward or the upward direction? Do you feel that body is going to move upward or downward? This case, the body is not moving either in the upward direction or the vertical direction. Is the body moving in the vertical direction? No, which means these two forces are balancing each other. N is balancing mg cos phi. Do you understand
Yes,
what I mean?
Yes,
Right? So the first condition of balancing is, this is N. Look at this. For balancing, the body is balanced. For balancing in the vertical direction, which are the two forces which are balancing each other? N must be equal to mg cos phi, correct? These two forces are equal and opposite. So that is the balancing condition in the vertical direction. Second one, in the horizontal direction, which are the forces? These two forces, because the body is just sliding down. In the horizontal direction, it is mg sin phi. So N is equal to mg cos phi. Horizontal direction, mg sin phi is equal to Fs maximum. Because these forces are balancing each other, the body is just beginning to slide. That's the condition we have taken. Now, can you divide equation 2 by 1? Can you divide this equation, boys? What is the value you are getting? I see. Sorry, Tanvir.
Ma'am, tan theta
Ma'am,
equal
against
to
IC.
fs max by n.
Okay, mg is sine phi. Okay, I'll go for the slides. Dividing 2 by 1, are you getting this? Tan phi is equal to fs maximum by n. So what is then tan phi? This becomes equal to mu s, because fs maximum by n is the coefficient of static friction. So in the previous slide, you had that is angle of friction, that was also equal to mu s in the previous case. So then we equate these both. So tan phi becomes equal to tan theta, or in other words, I can say the angle of repose is equal to the angle of friction. Yes or no, boys?
Ma'am.
Yes.
Ma'am, how is like fs maximum here?
Which one? No, the body is just
friction.
okay. The body is just beginning to slide. The body just begins to slide. Then the frictional force is always taken as the maximum static frictional force. So what is maximum static frictional force? That we call it as limiting friction. What is that? The frictional force between two bodies when one body just begins to slide. That is a statement. The frictional force, static friction is that the frictional force between both the bodies when the bodies are at rest. What is Fs maximum? Maximum static frictional force, or what we call it as limiting friction. It is the maximum static frictional force that comes into play when the body just begins to slide. Here, that statement is very, very important. When you are defining your angle of repose, what is the angle of repose? Angle of repose is the angle of inclination when the body placed on the inclined plane just begins to slide. Is that clear, boys?
Yes, ma'am.
Only this much. It's time, I think.
Now we can leave if you are done.
Yes.
Ma'am.
Boys,
Thank you.
Thank you, ma'am.
Thank you, ma'am.
someone, if needed, someone can
Thank
put
you,
this
ma'am.
on the slide. Yes, please. Just put a screenshot on the chat box.
Done, ma'am. Thank you.
Okay.
Thank you, ma'am.
Thank you, boys.
Thank you, ma'am.
Thank you, ma'am.